This video is about finding the average rate of change. In the unit of functions, functions are often used to model changing quantities. In this section, we're going to learn how to find the rate at which the values of a function change as the input variable changes. It's important in many contexts because you can find out how quickly the air temperature is dropping as a storm approaches if you're a storm chaser, or how fast revenues are increasing or decreasing from the sale of a new product. In the field of physics, this is basically where you could use this so much. So anyways, you could also in this course explain the difference between whether or not this is going to be a linear function or not a nonlinear function. Okay. So looking at the average rate of change, basically the average rate of change of the function y equals f of x, which is whatever determined function it is at the value x, between two x values, okay, of your ordered pair, is the average rate of change is a change in y over change in x. You may have seen it as delta y over delta x, or triangle y over triangle x, equals this, the function. Basically, this is the y value minus the other y value divided by the x value that goes with this y value minus the other y value. Now, what does that really mean? Well, what that means is that if you're going to find the average rate of change, you have to figure out basically the slope between any 2 points on this line. So when you take this f of b minus f of a, you're really just finding out the vertical change, the y value change, or the change in vertical motion, okay, divided by the horizontal motion, which is where they get this b minus a business from. So really, it's the vertical change divided by the horizontal change. Okay, and that makes it look a little more, hopefully, understandable, and says this is the line that passes through the ordered pair a comma f of a, which is really x comma y at this point, versus and b comma f of b, which would be this point. So in the next few minutes, we're going to show you how to do this, and basically we'll give you a problem like this one where you're going to be given a function and you have to find the interval between 1 and 3, and then the interval between 4 and 7. And then I'm going to give you a problem that gives you this problem. It's going to be changed a little bit about an object being dropped from a tall building, and it's going to be between 1 and 5 seconds. The average rate of change between 1 and 5 seconds, like it says right here. And I'm going to change this to show you between the 3 seconds and 8 seconds, and you'll see the difference in the rate of changes. Again, if the rate of change is the same for all instances, it is a linear function because linear functions have a constant rate of change, where nonlinear functions don't have a constant rate of change. So, well, let's get started. So finding the average rate of change for this problem says for the function f of x, where the function is f, at the value x, given the function equals x minus 3 in parentheses squared, whose graph is shown. So this is y equals x minus 3 in parentheses squared. Find the average rate of change between the following points. So what you do here is you make your table, x comma y, okay, and then what you do is you figure out where x is 1 right here, where x is 1, y equals 4. So this is the ordered pair 1 comma 4. And normally you can just read these right off the table at this point in your math career. The next one is 3 comma 0. And what you have to do is you have to figure out how these change. So how does 4 become 0? Well, basically you subtract those, you'll get negative 4. And how does 1 become 3? Well, you add 2. In this column, you figured out that's the rate of change for the y. That's the change in y. And over here, that plus 2 is the change in x. In order to find the rate of change here, basically you just put the change in y over the change in x like you did last year. So you'll have negative 4 divided by 2, which basically the slope becomes negative 2. And that makes sense here because this slope is downhill. Okay, we're going to look at this part of the curve now. So what it's going to ask us to do now is find the average rate of change between where x is 4 and where x is 7. So when x is 4, basically the y value is 1, just by reading that point off of there. Over here, when x is 7, y actually is 16. Again, just by looking at the graph, you can see what points have been given to you. So anyways, 4, 1 goes in first, because it's really leftmost. Rightmost goes next. Okay, so anyways, you're going to find your change in y. And how does 1 become 16? Well, you guessed it. It's plus 15. And how does x become from 4 to 7? Well, the change in x is going to be a positive direction as well. So the change in y over the change in x is going to be 15 over 3, which actually 15 divided by 3 is 5. And you notice that it's a steeper but yet uphill slope. So over here it was negative 2 slope. Now it's a slope of 5. This would indicate that this is not a linear function, because the slopes, or the average rate of change on a linear function, would always be the same. Here's another problem that I'm going to show you where they don't give you a graph, they give you an equation. And I'm going to do the same exact thing, but it's a different equation, so I'm not going to get the same exact answer. It says if an object is dropped from a tall building, then the distance it has fallen after t seconds is given by the function d for distance of t at the time of whatever they give you equals 16 times t squared. It says find its average speed or average rate of change over the following intervals. So I'm going to do the intervals between 1 and 5 seconds first. What I like to do for these kinds of problems is I make a 4-column table, or actually a 3-column table. I'll put x here. I'll put my workspace right here. Well, d is really going to change it to x. Equals 16 times x squared. And here's my y. Mrs. Edmonds may want to have you keep this as t. And go ahead and do that. That's fine. But anyways, these would be t's as well. So anyways, they want you to go between 1 and 5 seconds. Well, I don't have the y value, so we're going to have to just substitute that 1 into this equation. So 16 times 1 squared, well, 1 squared is 1, times 16 is 16. Okay. The next one is 16 times 5 squared. 5 squared is 25. And 16 times 25, well, we'll just say that's 400 for this time. All right, so now what we have is a table that shows us our values. The ordered pair would be 1, 16 and 5, 400. The change in y here would be 400 minus 16, which happens to be 384. In this case over here, the change in x, well, that's pretty easy. That's going to be 4, because 5 minus 1 is 4. So what I'm going to do here is I'm going to say that the rate of change in y over change in x, that's just a triangle. That means change. Okay, I'm sure you've seen it before, but if you haven't, that means the change in x. I'm too lazy to write change, e, 2 times. So anyways, you put that up here, 384, and then put the subtracted amount there for the x's, the change in x, which is 4. And then you figure out that that's going to go in. So your slope here actually would be 96. Just a quick check to see if I'm not being ridiculous right now. 4 times 9 is 36. Drop 2 down, 4, yeah. It goes in 6 times. So yeah, 96 would be the rate of change there, between 1 second and 5 seconds. So to find the average rate of change for this interval between 3 seconds and 8 seconds, we're going to set up our table again. I'm going to have a 3-column table with my x value here. I'm going to change this d of t to d of x equals 16x squared. Again, if Mrs. Edmonds wants you to keep that as d of t equals 16 times t squared, then obviously keep it that way. I'm not sure what the implications are for points on your test in June. But anyways, just to keep going forward here, what you have to know is between 3 seconds and 8 seconds. So anyways, what you do is you substitute this 3 in for where the time would go, 16 times 3 squared. And for this one, it would be 16 times 8 squared. To figure out the y value, or the amount of distance the object had fallen, is figuring this out at 3 seconds is 3 times itself, or 3 squared is 9. 9 times 16 is going to be 144. In this case, 16 times 8 squared is 16. 8 squared is 64, so 16 times 64. And I figured this out previously, so this answer actually would become 1024. So at this point, you're going to notice when I find this change in y, I'm not going to know that off the top of my head, and just for the sake of doing any problem, what you really do is you subtract these two values to find out the rate of change for y. So that would be basically 880. And over here, the rate of change for x, or the change in x, would be 8 minus 3, or just plain old 5. So in this case, your rate of change would be change in y over change in x. Again, I didn't want to write the word change y and then the word change x, so I used this triangle, which means the same exact thing. I could have put the subtraction on the top here, but anyways, I did that right there. So my rate of change for the y over x is 880 over 5. And if you figure that out, 880 divided by 5 is actually going to be 176. Now, on the last problem, I just said that the rate of change was 96. But actually, if you put this into context, which you're going to have to do this year, is the rate of change in this problem between the interval of 3 seconds and 8 seconds is 176. I'm assuming they say feet, but it's not just feet, it's feet per second. And if you look at the previous problem, this slope of 96 in context would be 96 feet per second. So if you look at the two problems, you'll notice that the rate of change is not the same, and this would be good proof that this is not a linear function. Aside from the fact that this has a squared, and you could tell by the equation it's not linear, but if you had to talk about a function and explain why, you would go and look at the slopes between two different intervals, like between 1 to 5 seconds and 3 and 8 seconds, compare the two and say, oh, therefore, this is not a linear function, because the average rate of change is not the same. That concludes this portion of finding the average rate of change. Hope you enjoyed this video. If you have any questions, please ask Mrs. Edmonds or myself, Mr. Brown. And good luck in your study of math. Thank you.